if we can get these last few knocked out. They're all dealing with direct and inverse variation. So what you've got to do is, let me just kind of review. Direct variation would be y equals k times x, and what you'd have to do is you'd have to find the value of k. If it's inverse variation, that's going to be y equals k divided by x, and again, you'd need to fill in the k. If it says jointly, that'd be y equals, typically it's k times, typically it's x and z or two other variables. They're all multiplied, and again, you're looking for k. So here, y varies directly as z, so that would be y equals k times z. Let me, sorry about that. There was something coming through the speakers in the room and I couldn't pay attention. So, okay, y varies directly as z, so y equals k times z directly, except it wasn't x, it was z, and y is 23 when z is 161. So to solve for k, I would divide both sides by 161. So that cancels. K equals 23 over 161. So I just rewrite this problem, but instead of k, I put 23 over 161. Oh, I guess that's going to reduce. I didn't even think about that. I'm like, that's not an answer. So let's see what 23 over 161 is. And 23 divided by 161, math, enter, enter, is 1/7. So instead of 23 over 161z, we're going to rewrite that as y equals 1/7 z. So my answer is B. Okay, number 45. Y varies inversely is x. So that's going to be y equals k divided by x. And we've got to find k. Y is 8 when x is 18. So I've got to figure out what k is. So I'm going to multiply both sides by 18 equals k. 18 times 8 is, I think, let's see, 18 times 8 is 144. I was right, but I didn't want to guess it. Is 144. So k is 144. So I'm going to rewrite this equation, but instead of k, I'm going to put 144. So y equals 144 divided by x. My answer would be A. Number 46 is a word problem. Your favorite. The speed of a vehicle is, so I'm going to put S equals inversely proportional, so that's an inverse, k divided by, inversely proportional to the time, so k divided by t, that it takes to travel a fixed distance. If a vehicle travels at a fixed distance of 35 miles per hour, that's the speed, in 40 minutes, how fast must it travel to cover the same distance in 50 minutes? All right, let's figure out what our value of k is. So multiply both sides by 40. K is 35 times 40 would be 1400 equals k. So the speed will be 1400 divided by the time. So what they want to know is how fast, in other words, what speed to cover the same distance in 50 minutes. Now obviously if they did do it in 40 minutes and now they're going to do it 50 minutes, you would expect their speed to be slower. So be careful. If you get a faster speed, there's something wrong. You got to slow down for it to take you longer. So the speed will be 1400 divided by, and this time it's going to be 50 minutes. 1400 divided by 50 is 28. So 28 miles per hour. 47. The distance that a spring is stretched by a hanging object varies directly, so that's k times, varies directly as the weight of the object. All right, if an 18 kilogram object, so that's the weight, stretches a spring 67 centimeters. So first we've got to find k. So divide both sides by 18. K is, and this is probably going to be a decimal, 67 divided by 18. 67 divided by 18. 3.7. I'm going to leave it 67 over 18. I don't think that reduces. I'm just worried about if you put 3.72, it probably would work out. I just hate to round and then be rounding my answer. So I'm going to leave it 67 over 18. So the distance equals 67 over 18 times W. How far will a 25 kilogram weight stretch? So if the weight is 25, how far will it stretch? 67 over 18 times 25 is 16.75 over 18, which is 2,326.38. That's not an answer. 67 over 18 times 25. All right, let me pause this. Okay, I think the problem was that I entered times 25 twice. Let me try this again. 67 divided by 18, enter, times 25 is, that looks better, 93.05, looks like 93.06 would be my answer. Sorry about that, but if I start again, I would have to do 6 more minutes of recording, so I just wanted to figure out what happened. So, 48. The pitch of a musical tone varies inversely, so that's k divided by, as its wavelength. So one tone has a pitch of 231 and a wavelength of 17.1. So if that is true, we've got to find k. K would be 231 times 17.1. 231 times 17.1 gives me a value of k of 3,950.1. So 3950.1 equals k. So it says find the wavelength of another tone that has a pitch of 269 vibrations per second. So the P would be 269, the K is 3950.1, and we need to find the W. And some of you had some questions. How do I do it if W is on the bottom? Well, the easiest way is just to do what you would normally do, to multiply both sides by W, get rid of what's on the bottom, so that cancels out. And so W times 269 is 269W equals 3950.1. Divide by 269, and I believe if you do 3950.1 divided by 269, you get 14.7. Let's check it. 3950.1 divided by 269 is 14.68, 14.7. All right, 2 more right quick. 49, y varies inversely as the square of x. So square of x would be x squared. Inversely means you divide. Y is 7 when x is 4. So that is k over 16. 4 squared 16. Multiply both sides by 16 to solve for k. And 16 times 7 is 112. So k is 112. So I'll rewrite this problem, but instead of k, I put 112. So y equals 112 over x squared, which is a. Last one. 50, y varies jointly as x and z. So k times x times z. Y is 18, but x is 3, and z is 3. So the first thing I'm going to do is multiply 3 times 3. So k times 9, divide by 9. You get that k is 2. So I'm going to rewrite this, but instead of k, I'm going to put 2. 2xz. So my answer is D. Good luck on your test. That's all of them. Bye.